lecture we talked about frequency hopping. Okay, and what happens in frequency hopping? The frequency of your signal keeps on changing after a particular interval of time. So it cycles through it, and for some time it is in one frequency, and after that for some time it is on another frequency, then it is on another frequency, then it is on another frequency, and this way it goes on until it finishes all the frequency. Then it comes back and it starts again. So that is frequency hopping. This is direct sequence. What happens in direct sequence that you have a chips generator. Basically, this is your PN sequence. This guy generates PN sequence. It gets multiplied or modulated with the original signal. Okay, and after that you get a signal which is a spread signal. Means that it is going to have much higher bandwidth than the original signal. Okay, this is an example. If your original signal is this one, the red signal, where you can see this is bit 1, this is bit 0, and this is bit 1. And this is these are your chips. Okay? And why we call them chips? Although they are bits, okay, but we call them chips because in this case the bit duration is much higher or much more than the bit duration over here, right? So they are very small. So for each bit you have how many chips? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So for each bit you have 11 chips. Now the sequence, the pattern is looks like a random wave for anybody who tries to catch your signal. That's why it's called PN sequence, serial random sequence. So when it gets multiplied with this, what you get is this red signal. And since this is 0, so it is reversed for the case when you have a bit 0, and for bit 1 it remains as is. On the receiver side, he knows what PN sequence you have used. So using that PN sequence, he is able to recover your original signal. So this is called direct sequence spread spectrum, or DSSS. Now since this signal is going to take much higher bandwidth, right? Why? Because the duration of this is this much, and the duration of this is very small, right? So the time that it takes is very small. So the reverse of time is frequency. So this signal is going to take a much higher bandwidth as compared to this signal, right? And that's why it is called a spread signal. So what we try to do is we try to send the data of several users in one bandwidth so that the bandwidth is safe. So basically, if special types of PN sequences are used that allow the combining and spreading of the spread signals, then bandwidth can be shared. So for example, you can have 32 users, okay, sending the data in the same bandwidth. Just like in FDM, in frequency multiplexing, you have one bandwidth, okay, but many users are sending their data. So over here, it's in a different way, but the idea is the same, that in the same bandwidth, you select your PN sequences in such a way. Let's take an example. Let's suppose you have 32 users. So each user is given a PN sequence. So in this way, you will have one PN2 all the way up to PN32. You will have 32 different PN sequences for each user. Okay, but these PN sequences are chosen in such a way that when you modulate using these PNs and then you add them and send them, then at the receiver side you are able to recover all of them. Okay, they have certain properties that you can recover at the receiver if you choose a certain types of PN sequences. Okay, now this is a very simple problem. What is the minimum number of bits in a PN sequence if we use FHSS, which is frequency hopping spread spectrum, with a channel bandwidth of 8 kHz and spread bandwidth of 100 kHz? Okay. The way to solve such problem is that this is your original signal, right? And he told you that the bandwidth of here is 8 kHz, right? Then he says that it goes to a spreading process, so that means it goes to a spread spectrum system. Okay, and what comes out is another signal which has a much higher bandwidth, which is 100 kHz. So this is the bandwidth of the signal that has been spread after spread. Now he's asking that how many bits you need to use. The thing is that first of all you have to see that how many different frequencies you need. So 100 divided by 8 gives you how much? 1, 2. So it is 2.5. Right? So you need 12.5 different frequencies if you want to increase the bandwidth from 8 to 100 kilohertz. Okay. So how many bits should I use to get 12.5 different sequences?
8 combinations, so 3 bits.
Well, I need 12 and a half different combinations.
You can't do it. It should be
So,
look to.
Yeah, so then why 8?
That's the maximum combination.
See, what he's trying to say is that since we can use, either we use 2 bits, right? In which case we have how many combinations? 4 combinations. If we use 3 bits, it's going to be 8 combinations, right? So either we use 3 bits, in which case we will have 8 combinations, right? Or we use 4 bits, so that we have 16 combinations, right? So we will go with this one, right? So that we use the 12 for this guy, and the 4 will not be used, they will be unused. Are you getting the point? Let's go back to the diagram in case it isn't clear. Let me go back to the solution is here. I'll show you the solution. But let's go back to this text. See, this is how it is done, right? So in the case of 8, you have assigned a frequency to each one. Okay. Now in this example, what we were doing, instead of 8, we had 16, right? So what's going to happen is something like this, that for 0, 0, 0, you have a certain frequency, right? Then for 0, 0, 0, 1, you have another frequency. All the way up to, for example, 12. How much is 12 in binary?
1100.
Sure? No. No. This is 0,
1, 0, 1.
2, 3.
1, 0, 1,
No,
0.
he's right. Okay, so up till here, you have 1, 2, all the way up to 12. So you have certain frequency for these. But after this, okay, you don't have anything. You don't use them. Like in your table, you will have only these entries. And these will never be used. So in this one, you will not have these ones. Right? You will only have these. That any combination of these. Is that clear? Again, what is happening in this case? I have 3 bits. So 3 bits means I have 8 different frequencies. Based upon that, I have generated this PN sequence. Okay, so you can see that I have a random kind of sequence. First, it is 101. Then it is 111. Then it is go there. So it keeps on jumping. But the thing is that this one contains all of these, right, in a different sequence. Not in this sequence, but in some other sequence. In our example that we just did, we are using 4 bits. Okay, 4 bits means I have a table like this, but it goes all the way up to 16, right? But I only need 12. So what I'm going to do, I'm going to assign a frequency to each one of them up to 12, right? And the rest of the 4 I will not use. So they will not be here in the table, right? And they will not appear here. So here I will have, like here, I have 3 bit combinations. How many? 1, 2, 3, 4, 5, 6, 7, 8. In this case, I will have 12 such things. Okay, 4 I will leave.
Doctor,
Yes.
should my signal include all of these?
Yeah, it will include all of them. Yes. It's not your signal. It is the PN sequence. This is only going to tell you that at which point, which frequency your signal will be using. Based upon this, like this is 101. So that tells that my signal will be at a frequency of 700 kilohertz. For some time it will remain at 700 kilohertz, right? After that it will jump to 900 kilohertz, a higher frequency. Okay, then it will slow down to 300 kilohertz.
Yeah, I meant that if the signal is not jumping very much.
The signal will be
If
jumping
it's-
based upon these.
Yeah, I'm saying if it's repeating itself maybe 2 times 200 kilohertz, 2 times 400 kilohertz, and 1 times 900. So I don't need all this combination.
No, it's the thing is this is telling you, or this is what it is trying to do. Is it's up to you what sequence you want to use, right? If you're using this sequence, then you have to follow this. If you're saying that you need your signal to be at 200 kilohertz 2 times, right? So your sequence should not be like this, and it should be like this. 0, 0, 0. You want it first to be 200, and then again you want it to be 200, so you will use.
Yeah, if I don't want 300,
Yeah, if you don't want 300, so you will remove it.
don't
from
put
it.
it here. Yeah, that's what I mean.
Yeah, exactly. So if there are 8, you don't want to use 8, fine. You want to use 7, you can use only 7. And which ones you want to use, you can put those. Yeah, definitely. And even in this case, you don't need to use them in sequence. You can choose any 12 that you like and leave out the rest 4. Okay, clear? So this and this is the solution, right? Any questions? Okay. These are the problems, and then this finishes the chapter.